Okay, let's do the one for sine, and let's see if we're going to implement those Bush techniques, Well, here we have again, and of course, when we're developing the formula, we always use integration by, uh, by parts, because it's an integration by parts question. So developing the formula, we use integration by parts. So here, first thing, we would say, well, let u be equal to x to the n, of course, because it's what's going to be the u, because the algebraic term. Okay, when you have an algebraic term, make it the u. That would mean du dx is equal to nx to the n minus 1. Okay, I don't know what I did here. Let me remove this and put an equal sign. Right, and that would mean du is equal to nx to the n minus 1 dx. Okay, dx goes to the other side. It's now like that. Now, dv is this part, sine x dx. So dv is equal to sine x dx, because integration by parts says integral of u dv is equal to uv minus integral of v du. Okay, kind of like that. So now what we're going to do is to now say that means v, if I integrate both sides, b is the integral of sine x with respect to x. And v is equal to negative cos x. Okay, because that's the integral of sine x, it's negative cos x. Now, what are we going to do? We implement this. So that means the integral of x to the n sine x dx, okay, is equal to uv. What is my u? X to the n. What is my v? Negative cos x, okay, and then minus integral of v du. What is v? Is negative cos x again. Du, what is my du? Is n x to the n minus 1 dx. Okay, so we go again now. What are we going to have? Is the integral of x to the n sine x dx is therefore equal to, negative comes in front, negative x to the n cos x. This negative comes out, it becomes plus integral of cos x multiplying n x to the n minus 1 dx. And of course, we take out the constant n, so we write integral of x to the n sine x dx is equal to negative x to the n cos x. Then, of course, the n comes out, so it'll be plus n, the integral of, we can write the x term first, like here, x to the n minus 1 cos x dx. We check, is the integral the same as this one? No. This one is in the form of a cos and this one is the form of sine. So we have to do by parts again. By parts for this one. Okay, this one. So we'll say, okay, before we bring it back into this formula, let's just do by parts for this part. Okay, so we can say the integral of x to the n minus 1 cos x dx. We would say let u be equal to x to the n minus 1. That would mean du dx would be equal to n minus 1 x to the n minus 2. And that means du is equal to n minus 1 x to the n minus, x to the power of x to the power of n, x to the power of n minus 2, and this is times dx. And therefore I can now say my dv is equal to this one, which is cos x dx. And that means v is the integral of cos x dx. And that means v is equal to sine x. Really? Yeah. So now I know what my my integration by parts formula says. It says integral of u dv is equal to uv minus integral of v du. So that means the integral of x to the n minus 1 cos x dx is equal to uv. It's u is x to the n minus 1. V is sine x, so times sine x. Okay, and then minus integral of v again, which is sine x, du. Du is now n minus 1 x to the n minus 2 dx. Wow. And what we can do, we can now put back this, okay? This comes from here. So we can now put it back. So we can say the integral of x to the n sine x dx is actually equal to negative x to the n cos x plus n multiplying this whole thing now. That's x to the n minus 1 sine x minus integral of sine x multiplying n minus 1 x to the n minus 2 with respect to x, you close. So this now we would say integral of x to the n sine x with respect to x is equal to negative x to the n cos x, okay? Then here we can say plus nx to the n minus 1 sine x. And then here, okay, here would be having, maybe let me not expand yet. Let me leave it like this. And outside, here I take out the constant, which is, so it will be minus n minus 1. The integral of n minus 1 is now out. Is the constant is now the integral of x to the power of n minus 2 sine x dx, okay? We've written it in the correct order now, starting with the algebraic term. So here I can now say it's equal to x to the n. So we say x to the integral of x to the n sine x dx is equal to negative x to the n cos x plus nx to the n minus 1 sine x, and then minus this n. So plus n times minus that, it will be minus, okay? Minus n multiplying n minus 1 multiplying the integral of x to the n minus 2 sine x with respect to x. And if we say let this integral, the integral of x to the n sine x dx, be equal to integral of n, in, right? Then we'd say that in is therefore equal to negative x to the n cos x plus nx to the n minus 1 sine x, okay, minus n by n minus 1 again. What is this now? This is x to the n minus 2 sine x in the same form, but this is now n minus 2, so it will be I of n minus 2. And that's it. So this is just how it goes. Now we can find out. It's now the same thing. So here we'd say, how did we develop this one? Well, again, we developed it the same way by saying we know our in is this one. So the first thing we'll do when we are developing the formula, we can say, let's develop it together. We'll say that if in is this, then the formula for it would be, it's like we do the integrate the product, isn't it? Derivative, right? But then always the first term we kind of like swap the sign, because if you remember in the example for cos, it was supposed to be negative, but we found out it was positive. And here it's supposed to be positive, but we'll find out it's negative. So it's going to be of course, the first thing is you leave the first term as it is, you differentiate the second one, it becomes cos x. Differentiate, but you put a negative in front. Plus, now you differentiate the first one, it becomes n x to the n minus 1, and the second one remains as it is. Then we just subtract n multiplying n minus 1, I to the n minus 2. That's it. And so remember the last part. N, it's minus, always you subtract. So it's going to be minus n times n minus 1, I n minus 2. So it's like it keeps going down. I is now n minus 2. There was an n, there's an n minus 1, and I is now n minus 2. Okay, that's how you remember it. Hopefully you can remember. Okay, leave the first term as it is, differentiate the second, but change the sign now. Put a negative in front, and then do the product true. Product true, you add true, leaving the first one, differentiating the second one, and then that's just how it goes. Okay? Hopefully you remember. Thank you for watching. Goodbye.